Hey everybody, it's Mr. Pizarnik here. I'm going to walk you guys through and demonstrate the Kepler's first law lab. You can do this at home with some pretty basic materials if you have them, and I'll show you what you need, and you can pause the video and go get them if you've got them. First of all, you're going to need a ruler. You're going to need 2 pins, thumbtacks, sewing needles, whatever you got there, and you're going to need a piece of string, and you're going to need a pencil. Okay, so basically our first step is we're going to take our piece of paper, and I'm just going to fold mine in half lengthwise because I want to do a good demo sheet here for you. Okay, and I'm going to fold it, and then I want to make sure it's not raised up or anything. You're going to need a piece of cardboard as well, a box. A pizza box works great for this. I'm going to take some pieces of tape and just secure my paper here. If you don't have tape, it'll be okay. The pins usually hold things in place, but it's a lot easier if you can tape it down so that it doesn't shift around on you. Okay, now I've bent this in half and I've got a nice crease there. And so I'm going to take my ruler and I'm going to put a dot about halfway, right in the middle. Okay, and then I'm going to measure from that dot. And the important thing, and I'm going to do this right now, one of these foci, okay, this dot right here is called a focus, plural, it's foci. I'm going to make my sun. And part of the law for Kepler's first law is that one of the foci is the sun, okay? And then I'm going to, from my small point, I'm not using the big sun here, but from my small point, I'm going to measure out. I'm going to put a dot at 1 centimeter. I'm going to put a dot at 4 centimeters. And I'm going to put a dot at 6 centimeters. Okay, so when you do this, if you can use a separate sheet of paper for each one, that's great. I'm just going to do it so that you can see all three directly compared to each other. So I'm going to put one pin into my box at the sun, which is my first foci. Okay, I'm going to put one pin in my 1 centimeter. And now I'm going to take my string. The loop needs to be between 6 and 8 centimeters long. So I'm just going to fold my string in half, right? Just like this. And I'm going to take that loop and I'm going to lay the end of it at 1 centimeter just to give me some idea where 6 to 8 centimeters are. I'm going to pinch it off at 8 centimeters so I know I need to make my knot. So all I'm going to do is I'm going to go over, make that little hole and go through. And before I tighten it, I'm going to lay it back down onto the ruler and make sure my knot, and I can kind of roll that knot down, and there it's at 6. So I know if I tighten it, I'll be somewhere between 6 and 8. Looks like I'm ending up right about 7, maybe 7.5. That's great. And I can take a scissors, I'll trim it, make sure it's pulled tight so it doesn't untie. Trim it off. You can leave those tails on, they kind of just get in the way. There we go. Now I throw it over those pins, and I've grabbed my pencil, and I'm going to start out. Just doesn't really matter where you start, but you're going to pull that string tight and just start to throw yourself a nice ellipse. Okay, if you got to go back and forth a few times to darken the lines, that's fine. Okay, my next one here, I'm going to go ahead, pull my pin, move it out to 4. Now, it's important, this was 1 centimeter, and I need to label this circle 1 centimeter so I know which ellipse it came from. Okay, I'm going to throw my loop over the pin again, throw my loop over this pin. I've done this a few times so the cardboard's starting to let the pin slide through. All right, and now I'm going to do that again. These will line up pretty much the same. because it's the same distance, the same loop from the sun. But with the real planets, they have different size loops. Okay, but watch how just changing, didn't change it much on this side, but it changes it a lot against that other foci. Okay, so that will be my 4 centimeter loop. And here comes my 6 centimeter. All right, so I'm going to grab that string again. And look how much more oval-like or elliptical that one's going to be. Right? Okay, so now that I've done that, I'm going to put my label here, 6 centimeters. And we've got our sun. We've got our point in space. Now we need to take our measurements, get our data. Okay, so we're going to go ahead and measure the major axis and the distance between the, pull this over here. So this is our lab. We need the ellipse or the foci, right? So that would be 1, 4, and 6 in those blanks. We need the distance between the foci, right? Again, 1, 4, and 6, and the length of the major axis. So we need to know what the major and minor axis are. So anytime we have a circle or a ellipse, well, I can't draw an ellipse very well at all. Well, I'm all set up to draw. So I'm gonna make myself a quick ellipse here for the labeling portion here. And this is why we folded that in half, or you can line it up across the pinholes. Okay. But from side to side, this is what's called the major axis. From here all the way over to here. So this is our major axis, and then our other are the foci points. This, if we cut this in half here, right, this would be the minor axis. So the squashed side of the ellipse. So we need this measurement from side to side for each of our different circles, or I'm sorry, ellipses. And we need to record that data because we're going to need that to calculate the eccentricity. So our first piece of data that we're going to get, I'm going to go with the 1 centimeter. So I'm going to measure from right here all the way to this point. And they all pretty much pass through that same point. So that is 13.5. So 1 centimeter between, and my major axis there is 13.5 centimeters. My next circle, or ellipse, sorry, is the 4 centimeter. So it's 4 centimeters between the foci. And that one looks like it is from here to right there, 10.5 centimeters. And the last one was my 6 centimeter between the foci. And that is 8.5 centimeters. Now from that, you should be able to complete the chart, okay? And you should be able to do the math to figure out the eccentricity, the ovalness of it. Also, if we're looking at, here's our sun, right? We need to identify the perihelion and the aphelion distances. And so we're going to take our measurement there. And the perihelion is the closest that the planet will be to the sun. So right here, from the sun to this point right here is the perihelion. Okay. And from this point to the farthest point of its orbit, so from the sun, foci, to the farthest orbit distance is the aphelion distance. So you can also have that for the lab. Okay, hopefully you now have the data that you need. We created our data chart. You can fill in the data chart. You'll have to do the math and find out the eccentricities of these different orbits. Good luck. Thanks for watching.